In this session, we are going to discuss about 1. Measurement, the process. 2. Accuracy and precision. 3. Errors in measurement. 4. Significant figures. And 5. Example problems. Measurement, the process. Definition: measurement is the comparison of an unknown quantity with a known, standard quantity, unit. Steps in measurement. 1. Select the physical quantity to be measured, for example, length, mass. 2. Choose an appropriate instrument, for example, ruler, balance. 3. Compare the unknown quantity with the standard unit using the instrument. 4. Record the result as a number with its unit, for example, 2.5 meters. Here is an example for you. Measuring the length of a table with a meter scale and recording it as 1.25 meters. Next, we discuss on accuracy and precision. First, accuracy. It refers to how close a measured value is to the true or accepted value. High accuracy means the measurement is very close to the actual value. For example, if the true length is 10.0 centimeters and you measure 9.9 centimeters, your measurement is accurate. Next is precision. It refers to how close repeated measurements are to each other, regardless of whether they are close to the true value. High precision means the measurements are consistent. For example, if you measure 9.8 centimeters, 9.8 centimeters, and 9.8 centimeters, your measurements are precise, even if the true value is 10.0 centimeters. Difference: accuracy is about correctness, precision is about consistency. A measurement can be precise but not accurate, accurate but not precise, both, or neither. Next point we are going to discuss is errors in measurement. What are errors? The difference between the measured value and the true value is called an error. There are basically three types of errors. They are asystematic errors. Occur in the same direction every time, either always positive or always negative. Causes: faulty instrument calibration, for example, zero error in a scale. Imperfect experimental technique, for example, parallax error. Environmental factors, for example, temperature, humidity, can be minimized by proper calibration and technique. B. Random errors. Occur irregularly and unpredictably. Causes: unpredictable fluctuations in experimental conditions. Human estimation errors, for example, reading between scale marks, can be minimized by taking multiple measurements and averaging. And C. Gross errors. Usually due to human mistakes, for example, reading the wrong scale, calculation mistakes, can be avoided by careful work and double checking. Now let us learn, how do we express errors? First, absolute errors. It is the difference between the measured value and the true value. Absolute error is equal to measured value minus true value. Next, mean absolute error, the average of absolute errors over several measurements. Then, relative error, ratio of mean absolute error to the true value. Relative error is equal to mean absolute value divided by true value. Next, percentage error. It is nothing but relative error is expressed as a percentage. Percentage error is equal to mean absolute value divided by true value multiplied by 100%. Next topic we are going to discuss is significant figures. In physics, a significant digit, or figure, is a digit in a measured number that is known reliably, plus the first digit that is uncertain. These digits indicate the precision of a measurement. Rules for counting significant figures. 1. All non-zero digits are significant. 2. Zeros between non-zero digits are significant. 3. Leading zeros are not significant. 4. Trailing zeros are significant only if there is a decimal point. Next, let us see, what are the rules for counting significant errors? All non-zero digits are significant. Example, 123.45 has 5 significant figures. Zeros between non-zero digits are significant. Example, 1002 has 4 significant figures. Leading zeros, before the first non-zero digit, are not significant. Example, 0.00456 has 3 significant figures. Trailing zeros, after the decimal point, are significant. Example, 2.300 has 4 significant figures. Trailing zeros in a whole number without a decimal point are not significant. Example, 1500 has 2 significant figures, unless specified otherwise. Now let us see how rounding off is done. If the digit to be dropped is less than 5, leave the last retained digit unchanged. If the digit to be dropped is 5 or more, increase the last retained digit by 1. For example, 2.346 rounded to 3 significant figures is 2.35. Next point we are going to discuss is the significant figures in calculations. First, let us see in addition, the result should have as many decimal places as the number with the least decimal places. For example, 12.11 plus 18.0 equals 30.1, 1 decimal place. Next, in multiplication, the result should have as many significant figures as the number with the least significant figures. For example, 2.5 times 1.25 equals 3.1, 2 significant figures. Here is an example problem solved for you. You measure the length of a rod 3 times as 2, 34 meters, 2.36 meters and 2, 35 meters. Mean value is equal to the sum of all values divided by 3, that is, 2.35 meters. Absolute error equals, in first case, absolute value of the 2.34 minus 2.3 which is equal to 0.01, and in second case it is 0.01 and in the third case, it is 0. Mean absolute error is equal to the average of all absolute errors, which is equal to 0.0067 meter. Relative error is equal to mean absolute error divided by mean value which is equal to 0.0067 divided by 2.35 which is equal to 0.00285. Finally, percentage error is equal to 0.285%. Here is another example done for you. Here I am giving you some tips for reducing errors. 1. Use well-calibrated instruments. 2. Take multiple readings and use the average. 3. Avoid parallax errors by reading scales at eye level. 4. Record observations carefully and double-check calculations. Hence we conclude, measurement is the foundation of experimental science. Accuracy and precision are both important for reliable results. Errors are unavoidable but can be minimized and quantified. Significant figures reflect the reliability of measurements and must be handled carefully in calculations. Keep watching Chintasaala. I will be back with dimensions and dimensional analysis in the next episode. Keep learning.